Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 4.1.1. We're going to start off with the M&Ms, and in this case, we are learning about mathematical properties. We talked about these last week, where you can use the commutative property of addition and of multiplication to rearrange the order of terms that you're adding together or factors that are being multiplied together, and it is not going to change either the sum or the product. For instance, 7 plus 5 is going to be the same as 5 plus 7. So you can incorporate that when you are simplifying expressions, and it might actually make it easier to simplify those expressions mentally and not have to work through the whole PEMDAS order of operations and show a lot of work. One thing to note, it is commutative property of addition and of multiplication. We do not have a commutative property of subtraction because it does not work to rearrange the order of terms that are being subtracted. 7 minus 5 does not equal 5 minus 7. However, if you incorporate KFC and change 7 minus 5 to be 7 plus a negative 5, that's your workaround, because now that you are adding instead of subtracting, you are adding an opposite, you're adding the negative 5, but still, same thing. Now you can rearrange them because commutative property of addition applies. So 7 minus 5 was negative 2, and no, it's not. It's positive 2. And negative 5 plus 7 is also positive 2. So this would work where this one would not, because 5 minus 7 is negative 2. So those are not equal. And then the same can be said for division. 10 divided by 5 is 2, but 5 divided by 10 is 5/10. So they are not equal to each other. The workaround for division would be if you were to take 10 divided by 5 to rewrite that as 10 times 1/5. Now you're allowed to rearrange the order. So 10 times 1/5 is the same as 1/5 of 10, which is equal to 2. So it's always going to be encouraged that when you are subtracting, to change that to adding the opposite, and when you are dividing, change that to multiplying times the reciprocal, and then you're allowed to use commutative property. The same thing can be said for associative property. Associative property is how you group things. So, if you said 7 plus 5 plus 9, with the parentheses around the 7 plus 5, you are saying you are giving priority to adding these two numbers together first, then you take that sum and add it to the 9. But since all you're doing is adding, there's no reason to have the priority for the 7 plus 5. You could just as easily prioritize 5 plus 9 and get 14, and then add that to 7, and you will still get 21, whereas here you had 12 plus 9 was equal to 21. Same thing applies to multiplication. If you would prefer to multiply negative 6 times 10, there's no reason to give priority to the 5 times negative 6, because all you're doing is multiplying. So you can multiply them in any order you want, and you can choose to group these guys together first and do that multiplication before coming back to the 5. This does not work, just like with commutative property, it does not work with subtraction. So if you wanted it to work with subtraction, you'd have to do KFC and change everything to adding the opposites, so that now that you're adding positive and negatives together, now you can group them any way that you want. And I would say the same thing for the division. If you change that to multiplying times the reciprocal, then you'd be able to group them any way you want. But just leaving it as a division problem is not going to work. And then the last property is distributive property. This is that idea that if you are multiplying a number times a sum, you can break your sum into parts that are being added together and multiply this multiplier times each of those parts, and that would be the same as multiplying times the sum of those parts. So 8 times 24 is the same as 8 times 20 plus 8 times 4. So by understanding how this works, sometimes it's easier to do mental math. Like, I don't know what 8 times 24 is, but I know what 160 plus 32 is. It's 192. So our answer to this problem has to be 192. And I was able to do it mentally with the help of my understanding of distributive property. Okay, So let's go ahead and simplify these expressions. And so I would recommend, like we were saying, is rather than trying to do the subtraction, if I change this to 8 plus a negative 13, right? We did the KFC here. And then let's keep this as a negative 13. And instead of minus a negative 4, let's call it plus a positive 4. I think maybe I would like to add the 8 and the 4 together first and say 12 plus a negative 13. And now I know that there's one more negative here than we have a positive here. So when you're adding the two numbers together, you're going to do a subtraction. How many zero pairs go away? You've got 12 positives with 12 negatives, leaving you with one negative behind. So 13 minus 12 is 1, and you had more negatives than positives, so our answer is a negative. Here we've got 7 minus a negative, or I'm sorry, 4 minus a negative 7. So let's call that 4 plus 7. And then I'll leave that as plus a negative 2. So we end up with 11. And maybe I want to go back to subtraction if you want to, right? KFC works in both directions. I can keep flip change back to a subtraction problem because I know 11 minus 2 is equal to 9. And then in this case, negative 7 plus 3 plus a negative 20. We could go from left to right, or I could add these guys together first and say negative 27 plus 3 ends up giving me negative 24 for an answer. Now, when we are adding or subtracting or multiplying decimal numbers, we need to know how the rule works. When you're adding or subtracting, you will want to line up all of your decimals. And we'll probably want to put a placeholder here because we're going to be adding all the thousandths together first and carry anything over more than 10 thousandths to the next column. And these are all the hundredths we're adding together. These are all the tenths we're adding together. And these are all the ones we're adding together. So we want to line up our decimals so we can line up all of our place values. Because remember, these place values are like fractions with denominators of 1,000, 100, 10, and so on and so forth. So this ends up being 10 thousandths, so I'm going to carry that 1 over, and that is 4, 12, 13. Is that 13? Yeah, that's 13. 13 hundredths, so I'm going to put the 3 hundredths here and carry over the another 10 hundredths into this column, and that is 1, 2, 3, 6, 11. And then I carry over the 1, and that ends up being a 7. And so you don't need to have this 0 there. It doesn't serve any purpose to keep it there, so that answer is 7 and 1/13. When you're dealing with subtraction, this is really important, not only to line up your decimals, but also make sure that you put your zeros in here. Once you got your zeros in there, now you're going to have to do subtracting. And 0 minus 6, you can't take 6 away from nothing. You have to borrow some thousandths, 10 thousandths from your neighbor, but you don't have anything there either. So you have to go all the way to the tenths place, take the tenth and make it 10 hundredths. Then take that 10 hundredths and take one of those hundredths and make that 10 thousandths. So 10 minus 6 is 4, 9 minus 3 is 6, and now I got to do another borrow, so that's going to take one of that 1 and make it 10 tenths, and now 10 minus 5 is 5 tenths, and then 5 ones minus 1 is 4 ones. And so your answer is 4 and 564 thousandths. Now, some students like to do the counting up method, which works sometimes. Other times it might be a little confusing. If you're not sure if you've done all the borrowing correctly, you should do this strategy called adding up. So if you add these two numbers together, whatever you were subtracting by plus your answer, you should get 6.1 as your answer. So let's go ahead and check that. I'll change my color here. 6 plus 4 is 10. Carry the 1. 1 and 3 and 6 makes 10. Carry another 1. That makes 6 and 5 makes 11. Carry another 1, and that is going to end up being 1 plus 1 plus 4 is 6. Yes, that's what we started with. So that proves that our answer is correct. And then when we are multiplying, when you multiply, you need to keep track of the decimal places. So I'm just going to take 48 and the 6 and multiply them together. 48 plus, that's a 4 there, so 24, that's 28. So our answer to 48 times 6 is 288. But here, we've got to put the decimal back in. So the rule is count the number of decimal places and put it back into your answer. So your answer has to be 2 and 88 hundredths. Now, if you were to do estimation, you would look at this and say, okay, so that's a number between 4 and 5, and that's almost half. So half of 5 would be 2.5. So this answer is probably a little bit more than 2.5, and it is. It's 2.88. So that's the way to check to make sure that your answer makes sense and your decimal is hopefully in the right spot. All right, Tina's rectangular living room measures 15 by 18 feet. How many square feet of carpet will Tina need to cover the entire floor? So square feet would be the area, which the area model is to take your base times your height or your length times your width in the case of a room. And you get 15 times 18 is 270. And so we're going to label that as 270 square feet because we are counting the total number of squares that would fill the inside of that rectangle, which is, representing like the floor of this room. Now it says that the carpet that Tina likes is sold by the yard or the square yards. How many square yards would that be? And so a lot of times students think, oh, I'm going to take that and I'm going to divide it by 3 because there are 3 feet in every yard. And so I know that's how I do my conversion. And so they get an answer of 90 square yards, which is absolutely the most common wrong answer. But that is not the correct answer because we're not asking how many, in this case, how many feet are in 970, or how many yards would be in 970 feet. We're asking how many square yards. So I broke this rectangle down into parts where if it's 15 feet, that's the same as 5 yards, right? Because 15 divided by 3 is 5. And so if you break this into 1, 2, 3, 4, 5 equal sections, each one of them is 3 feet, right? 15 feet divided by 5 is 3. So each one of these represents 1 yard. So there's a total of 5 yards there. Same thing here, 1 yard, 2 yards, 3 yards, 4 yards, 5 yards. This one is 6 yards. So if we change this to 6 yards, 6 yards, and this to 5 yards, then our area has to be 5 times 6 is 30 square yards. And here they are, 1, 2, 3, 4, 5, 6. 5 rows of 6 is a total of 30 square yards. That is often a situation where students will get confused, and drawing pictures is a great way, especially when we're doing measurement and geometry, of helping us to visualize why we do what we do. All right, so something that we've done in the past, find the missing parts of each line. So before I can figure out what this part is, I need to know what each one of these sections is equal to. There's a total of 1, 2, 3, 4, 5, 6 sections. So 42 has divided into 6 equal sections, meaning each one is 7. So if each one of those is 7, then I can do a counting sequence and say this is 7, this is 14, this is 21, this is 28, that's 35, and that's 42. And the first 2 sections are 2 7s, which makes it equal to 14. This has 1, 2, 3, 4, 5, 6, 7, 8 equal sections. So 64 broken up into 8 equal parts means that each one of those parts is equal to 8. So this is 8, 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 and so on and so forth. The most common wrong answer here is when students do this: 8, 16, 24, 32, 40, and then 48. And they think, oh, this stops here, so my answer is 48. But no, we're taking this 8, this 8, this 8, this 8, and this 8. So 5 8s is 40. And then how many equal sections here? 1, 2, 3, 4, 5, 6. 24 divided by 6 is equal to 4. So this is a 4, this is a 4, this is a 4, and this is a 4. So that marked here has got to be 16, right? 4, 8, 12, 16, 20, 24. So our answer is 16. And now the last part. And notice no calculators. We really, really need for you to become proficient with your integer operations, specifically what is happening when you're multiplying these numbers together. 7 times -2 means you are literally taking -2 and you're adding it together 7 times. So there's 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is a total of 14 negatives. So that's our answer. 7 times -2 is -14. Now, let's look at problem C. If we did the same thing, you might be noticing that since the signs are different, you would multiply the two numbers together and your answer would be a negative, because you would take -3 plus -3 plus -3 plus -3 means you're going to have a negative answer once you add all of those together, right? -12. Here, this is essentially saying the opposite of whatever 3 times 10 is. So you get -30, right? Or if you use commutative property and flip that around, now it says you're adding the number -3 10 times. And so 10 times 3 is 30, but they're all negatives, so your answer would be -30. And then for the last problem, if you think about it in terms of how I said this at first, the opposite of whatever 3 times 10 is, here you could think of the same thing and say, take the opposite of whatever 8 times -6 is. And 8 times -6 is -48, so the opposite of that would be +48. So in these three instances, you are adding you are multiplying two numbers together with different signs, and so your answer always ends up being a negative. And in this situation, you're multiplying two numbers together that have the same sign, so your answer is going to be a positive. And that concludes our homework for today. 16 minutes. Yeah, I spent a little bit of extra time going over those properties and a little longer than I wanted, but still, information there. So good job. Let's move on to our next activity. Take care. Bye.